Hi, this is Andy from narcolepsypumpkin.com. If you haven't done already, why don't you click on subscribe and click on the bell. That way you'll get notifications about new videos. So far in this little series we've looked at the single responsibility principle and how that can apply to you, your team and your company. We've looked at the open-close principle and how that can apply to you, your team and your company. Episode 3, Liskov's Substitution Principle. So the general idea of Liskov's Substitution Principle is that any derived class should be completely interchangeable with its parent, and when it is interchanged with its parent, should not cause any detriment to the system running. It should run just the same with the new version as it does with the old version. Obviously implementation and possibly sort of deep down behaviour is going to have changed, but as far as the calling that external API, it will be the same and behave the same and won't cause any problems. A common example of how that can go wrong, i.e. you can pass something in that's a derived class and it doesn't behave as expected, is a common rectangle square. So you have a class called rectangle and you inherit that class to create a square. Surely a square is a rectangle, isn't it? Well, in mathematical terms, technically, yes it is. But if you think about the characteristics of a square in relation to a rectangle you can only change the width of that rectangle or the height of that rectangle. You could make both those lengths the same, so it would be a square, but that's not expected behaviour. You can change those independently of each other. With a square, you can't. So you change the height, it's also going to change the width. You change the width, it's going to change the height. So if you've got a class expecting the behaviour of a rectangle where it can independently change the height and width of that shape, when you pass it a square, you're going to get behaviour that's not expected because it's going to spring back and make all its sides the same. That's where the rectangle square example violates Liskov's substitution principle, in that the square, the derived class, cannot be completely interchangeable with its parent. Square and rectangle example makes you think, why are you inheriting from another class? If you're doing that for shared implementation, there's a chance you're doing it for the wrong reasons. You should be doing it for shared usage. What I mean by that is that the classes themselves and interfaces have a common use. It's very rare there's a reason for copying a common implementation unless you're using the old school open-close principle, where you're actually maintaining an existing implementation while extending it with something new. And that's also where you have to be careful of violations of Liskov's substitution principle when applying the open-close principle in its original form. If you're extending a class by inheritance and you override a method and make it do something completely different, then that is truly a violation of Liskov's substitution principle, i.e. you're making the behaviour of that change. Now it's fine if you're adding a completely new function because the old code isn't going to call that function, it doesn't know anything about it. So that is not a violation, and that is a true extension. It's where we're doing extension or re-implementation that we have to be careful we don't change the behaviour while we're changing that implementation. You can
in respect of when you're testing, you need to make sure you're testing behavior and not going too deep down into the implementation. If you're testing implementation, you're potentially exposing parts of your interface that you don't necessarily want anybody else to couple to just so you can test them. And leaving those edges exposed when they're not appropriate means you could end up with some unknown coupling or dependency, i.e. things depending on your code implementation application that you weren't expecting. Have you ever wondered what's caused that? If so, the post you need to look at is entitled Testing Implementations with Stiltskin and Garbage. If you're not familiar with the 1990s UK indie music scene, some of that won't make any sense whatsoever. I wouldn't really worry about those too much. The crux of that post is talking about testing implementations and how, if you're from a legacy code transition mindset, you can often end up with a lot of tests that are testing implementations because as a result of transitioning legacy code, bringing it under test, you can end up with some tests that are going a little bit too deep because you weren't sure where the actual behavior edges were at the time until you've refactored it all out. The crux of that is you need to go and tidy that stuff up, and that's the only real scenario where I will ever advocate deleting tests. If they are testing implementation and not behavior, then they absolutely need to go. Leaving those tests around, one, when somebody does a re-implementation or a refactoring, it could potentially break a test. So refactoring hasn't changed the behavior, it has changed the implementation. That should not break a test. If you're finding in your applications that a lot of tests are breaking, it's likely to be because you're testing implementation details as opposed to behavioral expectations. So thinking about you and how Liskov substitution principle can be applied. It's a very simple one, and it's a concept that I've already touched on in the first 2 episodes. That is, you should strive to make sure that somebody in your team can cover for you. If you're ill or you're on holiday, you really don't want somebody to call you up to ask you about the bit of code you wrote last week. And yes, I get that there are a lot of developers out there that think the things in their head are what make them valuable. Now, that is something that is not actually true. The thing that makes them valuable is being able to share that information and to teach other people and almost provide a complete replacement for their role. Because that is, in essence, the only way you're ever going to move up as a developer is if you can absolutely make your current role somebody else's. You need to make sure that the things that are in just your head are in as many people's heads as possible, because you want your team to be able to survive without you in it, whether that be for a short period or a long period. That's just the professional thing to do. To some extent, with larger organisations, you can also look at that being applied to multiple teams. If you've got a big enough organisation or application where there are more than one team working on the whole thing, but there are teams that specialise, you should try and make it so that another specialist team can substitute, possibly only in a generalist fashion, but they can substitute for your team. So in this episode, we've covered what Liskov substitution principle is. And we've looked at how not adhering to that principle can result in things like failing tests, unneeded dependencies on code you weren't expecting. We've looked at how that can apply to you and your team in the way of making sure that there are people who can substitute for you, i.e. making sure that your knowledge, what's in your head, is not just in your head. As much of that as possible needs to be shared with the rest of your team, and if you're in a big organisation that has multiple teams, try and share some knowledge between teams so potentially another team can cover for yours in a time of crisis. Next time, in episode 4, we're going to be looking at the dependency inversion principle, how that applies to your code, as well as potentially you, your team, and beyond.
I've been spending most our lives living in a coder's paradise. A slung Java once or twice, living in a coder's paradise. A C# is kinda nice, living in a coder's paradise. Tell me, why are we so blind to see that the one